So logical addressing is basically done by two different methods, IPv4 and IPv6. So what is the meaning is like, so whatever the devices are there, so there are different devices available uh, that are going to be connected through the internet. So once a device wants to connect to the internet, each device is having its IP address or uh, individual address that is uh, unique for each device. So if different devices are connected through the internet, they are having a specific unique IP address. Okay, so that IP addressing is basically called the logical addressing. Okay, so logical addressing is the one that will be provided to different connected devices to the internet, or basically a particular network, basically we can call it. Okay, so as there are different devices going to connect with the network, there should be unique uh, addresses. So there are different uh, types of addresses that are given. So out of that, the basic one is like IPv4 addresses. Another one is the IPv6. Okay, so IPv4 and IPv6. So initially IPv4 addresses are basically addressing system is basically implemented. So we will just going through the basics about the IPv4 addressing. So currently also IPv4 addressing is used along with the IPv6 also. So because there are some limitations to the IPv4 addressing, so that's why a new type of addressing system is uh, adopted, that is IPv6. So we will be starting with the first one, that is an IPv4 addressing system. So here an IPv4 address is a 32-bit address that uniquely and universally defines the connection of a device, for example, a computer or a router, to the internet. So if any device we are going to connect, it uniquely and universally defines the device with an address that is of 32-bit is called an IPv4 address. So all the devices throughout the world, if it is connected to internet, they will be having unique IPv4 addresses. So as there are large number of devices are being currently connected or connecting in future also increasing large number of devices. So there is a limitation to this 32-bit addressing also. So that is resulted into IPv6 that we will be saying later on. So in IPv4, they are unique in the sense that each address defines one and only one connection to the internet. So each address is there. So each address will be defining only one address. Two devices on the internet can never have the same address at the same time. If a device operating at the network layer has M connections to the internet, so if a device operating at the network layer has M connections to the internet, then it needs to have M addresses. So a device at network, in the sense, suppose a router is there. So if a router is there, if M devices are connected with the router, okay, so if M devices are connected, then there is a M number of addresses are required for this router or this network basically. So whatever the devices are there connecting to this network, if M number of devices are there, so M number of addresses are there required. The IPv4 addresses are universal in the sense that the addressing system must be accepted by any host that wants to connect it to the internet. So if anyone wants to connect with the internet, it has, has to be accepting the IPv4 addressing system. Okay, and that's why it is unique and universal. It is universally adopted. A protocol such as IPv4 that defines the addressing has a address space. So there is an address space. So what is the address space? So an address space is the total number of addresses used by the protocol. So whatever is the total number of addresses can be used by a protocol. So here, if a protocol uses n bits to define an address, so total number of address spaces will be 2 to the power n. So similarly, in case of IPv4, if 32 bits are there, then address space will be 2 to the power 32. So this much address will be available. So that is coming out to be around like 4 billion. Around 4 addresses if we are using the IPv4 addressing. So here an IPv4 address is of 32-bit long. IPv4 address are unique and universal that we have seen, and address space is 2 to the power 32, or it is this much. It is around like 4 billion. We can consider it approximately. So what is the notation? So there are two different types of notations are there for okay. So here for notations of IPv4 address, there are two different types of are basically used basically here. So IPv4 is represented in terms of a binary notation or a dotted decimal notation. So here in binary notation, IPv4 address is displayed as 32 bits, and each octet is often referred to as a byte. So it is common to hear an IPv4 address referred to as a 32-bit address or a 4-byte address. It will be a 32-bit address, or we can be calling in terms of byte as like it is a 4-bit addressing. Similarly, in case of dotted decimal notation, IPv4 address is more compact and easier to read. So here the internet addresses are usually written in decimal form and represented with a decimal point, that is dot, separating each of the byte. So in binary notation, there will be like 4 byte. So each byte will be represented by 8 bits. So byte 1, like byte 2, byte 3, byte 4. And in decimal, this byte will be represented in terms of its decimal equivalent. Byte 1, byte 2, byte 3, byte 4. And each decimal equivalent will be separated by a dot. So this dot is like decimal point. So this is how IPv4 address is represented. So you all might have encountered like how these are basically represented. You might have used that. So we'll just see some of the maths behind these numbers. So here is like it is asking for to change the following IP address from binary notation to dotted decimal. So this is like a binary notation of the IPv4 address to A and B is given. You need to represent it in terms of dotted decimal notation. So you need to just represent this number equivalently into the decimal value. So this is 1 0 0 0 0 0 0 0. So 4 and 8. So this is nothing but the 128. This is if we increase one extra here, so it will be 128 plus 1, that is 129. So this first byte is basically 129. Similarly, if we talk about this one, so starting 4 is 0. So it will be like that's no need. So it is like 1011. So this is 8 plus 3, 11. So its decimal equivalent is this is like binary. Here this is the decimal equivalent of 11. Okay, so similarly the 11 again, then this will be represented in its decimal equivalent. Similarly, if we represent each of the byte into decimal equivalent with a dot, that will be representing its decimal representation. So this conversion you might have gone through, binary to decimal conversion. Yeah, the same is here. Dotted decimal is given. You need to convert it into equivalent, binary equivalent. Okay. So this 111, that is 111, will be converted to binary equivalent as this. So in binary, if we are going to represent, we will not be representing with a dot. It will be like a complete 32-bit data. So it will be like complete 32-bit address. There is no dot is used. So this is about the converting. Next, we will see like find the error, if any, in the following IP address 4. So if any IP address, is there any error in that? So here, the first we will be saying, so whatever is the representation, we know this is 8-bit. So if suppose complete 111 8-bit is there, so 11114, 11114. If this is the complete 8-bit data, so all ones are there, its equivalent decimal representation will be like 255. So that means each decimal equivalent of the each byte has maximum value of 255. And what will be the minimum value? 0000. So it's binary. So its decimal equivalent will be the 0 itself. So that means each byte can be having a value ranging between 0 to 255. It cannot be less than 0 and it cannot be higher than 255. This is the basic idea. So here we need to identify if there is any error. So while representing it, so this is correct. This is correct. Here it is written 045. So whenever we are representing, we can't use 045. So here, so there must be no leading 0. So it is having an error. Next one is 221, 34.7.8.20. So here 1, 2, 3, 4, 5 byte is used, but IPv4 is only 4 byte. So no more than 4 numbers. So it cannot be having more than 4 bytes. So it can have only 4 numbers. So it is having 5 numbers. So it is error. Next one is 75.45.301. 301 is higher than 255. So it should be less than 2 or equals to 255. So there is an error at this location. Next one is here it is representing the combination of binary as well as the decimal. So we can only have either binary or decimal. We can't have the mixture of both for representing the IP addresses. Okay, so next is the classification of addressing. So IPv4 addressing is done in divided represented by like 2 different addressing modes. So one is basically called like the classful addressing, another one is called like classless. So classful addressing in the sense the IP address range, because it is 32-bit. So 32-bit means starting address will be like 32 times 00 and last address will be 32 times 1. So this complete address will be in this range only, starting with 0 to complete 1. So in between these two all possible addresses will be there. So there is a class, there is a criteria to identify different range of addresses. So these range of addresses are basically divided into a class. So that method is called the classful addressing. Another method is classless, means there is no specific class. It is you can use anyone at any time. So there is classless addressing. But in classful addressing, they are having these addresses are divided into different classes. So we will just see here. So IPv4 addressing at its inception used the concept of classes. At the starting of the IPv4 addressing, it uses the classes. Nowadays, it is not used. So this architecture is called the classful addressing. So in classful addressing, the address space is divided into 5 classes. So that classes are A, B, C, D, and E. So these are the 5 different classes that are basically used for addressing the IPv4 addresses. So class A addresses were designed for large organization with a large number of attached hosts or router. So class A were having designed for large organization. Similarly, class B were designed for mid-size organization with tens or tens of thousands of attached hosts and routers. And similarly, the class C addresses were designed for small organizations with a small number of attached hosts and routers. Class D addresses were designed for multicasting, and similarly, the class E is the reserved one, that is reserved for research and development. So these are the different class of uh, classful addressing of IPv4. So each class occupies some part of the address space. So complete address space we have seen 2 to the power 32. So starting with 0, maximum can be 2 to the power 32. Maximum can be 2 to the power 32. So out of this range only, these classes are divided. So this is the complete address space, and each class is taking some portion of this address space. So if the address is given in binary notation, the first few bits can immediately tells us the class of address. So how this class of address is basically identified, we will just see in the next slide. Okay. So the same is given into the figure here. So how we need to find the classes of the binary or the dotted decimal notations of the IP addressing. So here class A addressing. So first of all, IPv4 is of 4 byte. This is this first byte, second byte, third, and fourth. So class A, all the class A addressing, if representing binary notation, then class A addresses will be having fixed the last bit of the first byte. So in 1 byte, 8 bits are there. So 4 and then 4. So 8 bits are there. So out of that, the MSB bit is 0 fixed, and other bits can be changing. Okay. So if other bits will be changing means this yellow color means only the first byte. So other bits of this first byte will be changing. So the first will be like 000. The last address of this will be 0, then all ones. So because the first MSB bit is fixed 0, other will be changing of only this first byte, yellow box only. So it will be equivalent to 0, and this will be equivalent to like 127, because if this is 1 and all other one is 0, one higher than that, that will be equivalent to 128. So it is 0 to 127. So same is in decimal equivalent, it is 0 to 127. The same is the same, like different classes have been represented in either in binary or dotted decimal. Both representations are shown here. Next, in class B, the addressing will be starting with 1 and 0. So after 1 and 0, other 6 digits. So 6 digits like 1 and 0 is fixed. Then 6 digits will be changing. So it will be changing from 0 to maximum 1. Maximum it can be 1, and it will be fixed. So 10 will be fixed. So it will be equivalent to 10. Then all zeros means it is equivalent to 128. And this will be equivalent to 128 plus this number. So 128 plus this is like 64. Okay. If we add it, its equivalent will be like 191 here. Okay. So its equivalent will be coming out to be 191. So the next is here in the third case, here it is going to represent the first byte as 110, that is fixed. 110 is fixed. So the remaining 5 bits will be changing, and then maximum value is 110, then all ones. So that will be coming out to be 192 to 223. Then class D, for class D, these four bits will be fixed. So if 4 bits are fixed, remaining 4 will be 000 or 111. So for 000 and 111, this will be the decimal equivalent. Similarly, class E, these will be 111. So it will be then again 000, 4 remaining 0, then all ones. So all ones will be like 255. And if it is there, it's ranging between 240 to 255. So this is based on the number of bits in binary, or based on the range of the first byte, we will be first byte decimal equivalent, we will be able to identify like a particular IP address is classifying categorized into what categories. We can identify it. And this yellow colors are going to represent basically like we will see later like what is mask. Okay. So before that, we are having a question here. So find the class of each addresses. So here we need to find out what at what class these addresses are belonging to. So if this is the IP address 32-bit, so first byte leftmost bit will be representing the criteria to identify like what class it is belonging to. So it is 0. So you can just see here, if it is 0, so we can say it is belonging to the class A because it is 0. Next one is 110. So if it is 110, that means it is belonging to class C basically. It is belonging to class C. And the third bit is like 110. So starting to 1 and then 0. So it will be the class C. Next is 14. So 14. So 14 will be coming out because first byte decimal equivalent 14 is coming into this range 0 to 127. So it will be belonging to the class A. 252. 252 will be coming into this range 240 to 255 in between. This is there. So it is belonging to class E. So this is how we will be identifying like if a particular IP address, IP4 address is either belonging to what category. Okay. Yeah, so here the number of blocks and block size in classful IPv4 addressing is given here. So here, here basically this yellow color is going to represent the number of class here, a number of blocks basically. So here yellow color is then yellow color is representing only first byte, means only first byte is basically going to change. So starting with 0 to 127. So that means total 128 class will be there into total 128 blocks will be there. Blocks in the sense, so it is like starting with 000. So complete, suppose it is 000 is there, 8 zeros are there, and the remaining zeros will be there and 1 will be there. Remaining 24 bits will be either 0 or 1. So this is one class of address. Similarly, next class will be 0, then 000, then 1. So with this one, all 32 bits are 28, 24 bits will be 0 or 1. So this will be like one class. So class will be defined based on this yellow portion will be changing number of bits into this. So starting with 0, maximum will is 127. So total 128 is there. So 128 is the class. Similarly, in the second case, the class B, sorry, that is block. So in the second class, basically, it is 10. So it is 10, and then this is 000. So 10, then here is like six zeros is there. Then this yellow is there. So there 8 is also 0. 4, 5, 6, 7, 8. Then this is 10, and then all will be 1. 6, and then here 8. Okay. So this is the basic idea. Okay. So what is there is these two are fixed. Only changing how many bits are changing here. The 8 plus 6 total is 8 plus 6, that is 14. 14 bits are changing. So if 14 bits are changing, the maximum possible values will be 2 to the power 14. So if we do 2 to the power 14, it will be coming out to be 16,348. So it is 2 to the power 14 equivalent. So in the previous case also we can just think. So here one bit is fixed, remaining 7 bits are changing because yellow portion is having 8 bit. Out of that, 1 bit is fixed, 7 bit is changing. So 7 bit is changing means 2 to the power 7. So 2 to the power 7 is nothing but 128. Similarly, in the C, here it is 3 blocks are yellow. So this is how like 8 bit, 8 16 bit, and here 5 bits. 16 plus 5, that is 21. So 21 bits are changing. It will be changing, starting with like 21 zeros and then 21 ones. So if we make it 2 to the power 21, it will be coming out to be this value. That means this much of blocks will be there. And in each block, what will be the size? Okay, so this size will be basically going to tell like what is the value, like total size, in the sense this was the case, this 128 multiplied by this possible range. So this possible range multiplied by 128 means this is 8 24 to 2 to the power 24 multiplied by 128 will be the total block size basically here. Okay, so that will be coming out to be block size. So similarly, we can find out the block size and the number of blocks in each of the cases. So here, this is the basic idea about the IPv4 classful addressing. Okay, but there are some disadvantages to this classful addressing. So in classful addressing, a large part of the available address were wasted. So how it is basically wasted is like always here. You can just see here. Here this is 0 is fixed always. So if it is 0 is fixed, means we are going to waste large amount of range of the addresses. Here also 10 it is fixed, so it blocks many of the possible ranges into B. And here also in C, so here you can just see the block size is this much, and here the block size is this much, and the block size here is 256. So the disadvantage of block C is like here very limited number of users can be there, and here this is large number of users are there, but there is no organization that can be using this large amount of address for one block. Okay, so there are disadvantages like there are lots of addresses that are being not used. Okay, and also here reserved IP addresses are there. Okay, so some blocks are reserved, so there is some limitation to it. So lots of available addresses are basically wasted. So that's why there is a requirement of new addressing system that is called the uh, classless addressing. So before going with the classless addressing, there is a point that is called mask and subnetting and supernetting. So these points we will just see. So into a mask, this is like a class is given. So basically class A, B, C are basically being available for public use. Otherwise, D and E is not used for public. So basically class A, B, C will be used for public. So for the ABC class only, the masks are defined. So masks in the sense it will be having net ID and host ID. So this colored one is basically called the net ID. So whatever the number of ones are there, 8 number of ones are there. So this colored one will be like net ID and the remaining zeros will be the host ID. So for class B, this 16 bits are leftmost 16 bits are ones and rightmost bits are zeros. So this will be the this is basically the colored one and host ID is this one. So for each class, host ID and net ID and host ID is given. This is just to categorize and this complete. So net ID and host ID combinedly is considered as the mask basically. Okay, so in decimal equivalent, this is used. So here it is represented like /8 is given. So this it is called like classless inter-domain routing notation. So in classless representation notations, basically classless addressing, these points will be used. So this is like CIDR notation is basically called. So this masks that are given to 55.0.0.0 in CIDR, it is represented by like /8. /8 means only 8-bit, leftmost 8 bits are ones, all ones. Okay. Similarly, /16 means 8 plus 8. 16 bits are leftmost 16 bits are ones. 24 means 8, 8, 8. That is 24 bits are ones. Leftmost 8, 28, 24 bits are ones. So this either in classless case notations, this will be the way we will be representing the masks. In IPv4 classful, this is how the masks are basically used. So we'll be letting you know like what is a mask basically in later cases. Here's subnetting. If an organization was granted a large block of class A or class B, it would divide the addresses into several contiguous groups and assign each group to smaller networks are called subnet. So if a particular organization is getting some set of addresses from class A and class B, so if it will be giving the addresses in a group or in continuous group. Okay, so each continuous group will be assigning a smaller networks also. So suppose 20 addresses are given. So starting 5, starting 5, starting 5, starting 5. So these addresses will be considered as part of the one group. This is one group. This is one group. This is one group. So this will be divided into sub groups or sub networks. So that will be having a subnet, sub network, a smaller network. So it will be having some subnetting. So this process is called subnetting. Okay. So a complete network it has taken of 20 addresses. Out of that, it has divided into smaller groups. That will be the subnetting. Supernetting. So in class C, only limited number of 26 block size is 256 is the block size. So in class C, one block size will be given to an organization, and this organization will be creating a large range by combining different networks of class different addresses of class C. That will be called supernetting. Okay, and here address depletion is termed as the run out of class A and class B addresses. If there is a limited number of addresses into class A and class B, so if we are running out of the addresses, that will be called like address depletion. And a class C block is too small for most mid-sized organizations. So here there is no address to no IP address available to assign for a particular device or a particular host. Then it will be like considered like address depletion. So this address depletion is basically removed by the IPv6 that we will be looking at into the next class. So that is basically IPv6 will be removing the problem of address depletion. So this we'll see into the next class. Okay. So I hope you have